having fun with trig. I will be your hostess for today's show, and for our first topic, we're going to start with deriving laws of sines with Sergio.
To derive the laws of sines, first start by drawing a regular triangle. Label the angles A, B, and C. Label the sides A, B, and C. Draw the height. Okay. Now start with sine of B. Sine of B equals H over C. Sine of B equals H over C, opposite over hypotenuse. And then same thing for C. Sine of C equals H over B. Sine of C equals H over B, opposite over hypotenuse. Okay, so you want to get them to equal H, so you multiply C on both sides for this one. So multiply C, cancel them out, and then put H equals C times sine of B. You want to do the same thing for this side, so you want to multiply B, cancel them out, so it's H equals B times sine of C. As you can see, they both equal H. So you go here, and then so you put C times sine of B equals B times sine of C. You want to get the C by itself, so you divide sine of B on both sides. You cancel them out, so C equals B times sine of C over B, or over sine of B. So C equals B times sine of C. You want to divide it because you want to put it on this side. So you divide sine of C on both sides, you cancel them out, and then your final product is C over sine of C equals B over sine of B. And because this both equal, the A has to equal too. So it's A over sine of A equals B over sine of B equals C over sine of C. And that's the laws of sine. Only use laws of sines when you are given two sides and at least one corresponding angle, two angles and one side. The common mistakes when people want to derive laws of sines is just starting off the problem. So it's sine of B equals H over C, and sine of C equals H over B. It's right here.
My name is Brian, and I'm from Having Fun with Trigonometry, and today I'm going to be explaining to you law of sines. And the problem that I'm going to be using today is hot air balloons. And the problem is a hot air balloon that is held at a constant altitude by two ropes that are anchored to the ground. One rope is 120 feet and makes an angle of 65 degrees with the ground. The other rope is 115 feet. What is the distance between the 2 points on the ground at which the two ropes are anchored? And first off, you start by drawing out the information that you've been given. And here you can see the rope is 120 feet and the other one's 115. And first off, you start off by finding this angle right here, so you can find the angle at the top. And first, you use the law of sines the law of sines, which are A is equal to A over sine A is equal to B over sine B, C over sine C. And we use that over here, which you can move from here to here and calculate that within your calculator. And you plug it into your calculator the inverse sine of 0.9457, and your angle the angle B would be 71 degrees. And to find the third angle, you add up the two angles at the bottom that are from the rope and the ground, and you subtract it from 180 feet. And you get 44 degrees for the top angle. And using that final angle, you will be able to find the length between the 2 points at which the two ropes touch the ground. And you also use the law of sines right there by deriving it from here to here. In order to get the length of the ground. And the most common mistakes that occur are right here, between these two, from getting to this problem to this one. And from here you have to multiply sine B from both sides, and these two will cancel off right from this side, and basically move sine B over to the side of the equation, and that will turn into sine B times 115 feet over sine 65, and from there you multiply by sine 65 on both sides, which will cancel off the sine over here, which will then lead you to sine of B times 115 feet is equal to sine of 65 times 120, and from there you divide by 115 feet on both sides, which will cancel out the 115 on this side, and your final answer would come to sine B is equal to sine of 65 degrees times 120 over 115, which can help you to figure out the problem